Definition. Suppose you have two sets. Let A and B be two sets. We say that set A has the same cardinality or size of set B if and only if you can find one-to-one correspondence. You have a one-to-one and unto function. You have a one-to-one correspondence from set A to set B. So if you can find a function like f maps A to B and f is injective and surjective, or if you have a bijective function, then we say that the cardinality of A is equal to cardinality of B. Well, as you can see, cardinality is symmetric, it's reflexive, and also transitive. Just the theorem. Cardinality is reflexive. The cardinality of set A is the same as the cardinality of set A2. Cardinality is symmetric. That makes sense. If the cardinality of A is the same as cardinality of B, then for sure you can conclude that the cardinality of B is the same as the cardinality of A. And finally, cardinality is transitive. It means that if the cardinality of A is equal to the cardinality of B, and cardinality of B is equal to the cardinality of C, then the cardinality of first set and the last set must be the same. You can find those bijective functions. Example. Suppose 2z is the set of all even integers. We're going to say that, hey, the cardinality of 2z is the same as the cardinality of z. So what's the meaning of that? It means that I need to find a bijective function mapping 2z to z. Well, think about this function. I have my 2z and I have my z. Or vice versa. You can define any function that you like that is bijective. You can take some elements like 2, 1, 0, and map them as you see fit. So, for example, you can take 0 and map it to 0. You can take 1 and map it to 2. You can take 2 and map it to 4, and so on. You can take -1 and map it to -2. You can take the rest of them and map it to the rest of the even integers that you have here. Well, what is that function? Well, the function is crystal clear. This function f that maps z to integers, take on each n value and map it to 2n. So is this a one-to-one function? I just introduced a function. This function is one-to-one function, and also it is onto, for any y value, I can definitely find an x value that the x is mapped to y by this function. Obviously, this is a one-to-one function as well. If f of 1 to 1, if f of n1 is equal to f of n2, what's the meaning of that? By definition, 2n1 is equal to 2n2, dividing by 2, n1 is equal to n2. So this is one-to-one or injective. The function is also onto or surjective. For any y value, any y value in 2z, we can find x in z such that f of x is equal to y. Well, that's easy. Why is that? You can just define it as 2n. This n, this x, let's write n since we used n everywhere. This n is equal to y divided by 2. All of these are multiples of 2. So you can simplify that.